two proportion z-test and confidence interval. So what are the characteristics of proportion problem? The characteristic is the problem they do not mention mean, median, or standard deviation. For each sample, we have two samples. For each sample, the problem provides the number of success, which is x, out of the corresponding sample size n. So let me give you a very simple example. Let's say we have two schools, School A and School B. In School A, my sample size is 200 students, and then 150 of them drive to school. So the n is 200 and then the x is 150. In School B, I have 100 students and then 40 of them drive to school. So the n2 is 100 and then the x2 is 40. So out of 100 students, 40 of them drive to school. That's all you need from each sample. You don't need the mean, variance, and standard deviation. So the basic setup is you set up two proportions and put them in fraction, one for P1 hat and then one for P2 hat. So for a P1 hat and P2 hat, so we have to take the number of success divided by the sample size. The reason I use a P hat that is because in statistics, the hat, so this hat stands for estimation. Why do we use the estimation? Because sample is an estimation of the population. So sample proportion is an estimation of the population proportion. We are trying to use P hat to estimate P. We are trying to use sample to study population. So that's why we have a P hat. And then when you do your works, especially using a graphing calculator, or do not put the P1 hat and P2 hat in decimal. Just keep them in fraction, all right? So one big tips for you, keep them in fraction. Do not put them in decimals. Now, other than P1 hat and P2 hat, you also have to calculate the pole proportion, which is P hat. So pole proportion, which is you combine two proportions together by doing x1 plus x2 divided by n1 plus n2, and this is not an optional value. So for the pole proportion, you will need it, because let's take a look at the formula for a hypothesis test. So in the formula for hypothesis test, so we have z equals to P1 hat minus P2 hat, and sometimes in some textbook they also mention minus P1 minus P2, but usually they don't mention this piece, because in the null hypothesis they assume P1 equals to P2. So P1 equals to P2, then P1 minus P2 is just equals to 0. So that's why when you look into some textbook, they don't even mention the P1 minus P2. And then divided by, we have a square root, and then take a look. That is a pole proportion in yellow, P hat, and then multiply 1 minus P hat, and then you multiply 1 divided by n1 plus 1 divided by n2, that is for calculate the test statistics. And then for two proportion confidence interval in green, we have P1 hat minus P2 hat, that is plus or minus, that's a point estimate, and then you plus or minus margin of error, which is z half alpha times the square root of P1 hat 1 minus that divided by n1, and then you do the same thing for the second proportion. And then one note for you is, in some textbook they don't write 1 minus P1 hat, they call it a Q1, because 1 minus P is equals to Q. All right, and then when you do your homework online, I never ask my students to do this on a written test, but when you do homework online, 99% of the time they ask you to do this. They would like you to say that P1 hat minus P2 hat, which is the sampling distribution, follows normal distribution with mean P1 minus P2, which is equals to 0, because H0 assumes P1 equals to P2, and then you multiply the denominator of the Z formula, square root, pole proportion 1 minus that, and then multiply 1 divided by n1 plus 1 divided by n2. Okay, so when you do your homework online, like on website, they will ask you to do this. Okay, the sampling distribution follows normal distribution. They won't ask you to type the word normal. All you have to do is you put a capital N, and then P1 minus P2, which is equals to 0, and then the square root term, all you have to do is plug in and then calculate. Okay, so for null hypothesis and alternative hypothesis, for H0 and HA, one of the possible pair is P1 equals to P2, and then the HA is P1 not equal to P2. You can have greater than or equal to versus a less than or equal to versus a greater than. So in these cases, they are the opposite, and then sometimes you might encounter equal and greater than, equal in less than. So two things to remind you is number one, never use equal in HA. Okay, do not use equal in HA. Never use equal in HA. And then number two is do not use P hat in HA. So when you do the Z test and the the two sample Z tests, do not put X bar in HA, because for X bar and P hat, all we have to do is to take a sample and find out. Right? So you don't need to carry a test for it, right? But for the population is big, so we will have to carry out a test to study the population. But for sample, we don't need to carry out any test. All you have to do is grab a sample and then find out the number of success. So that's why never use P hat in HA. Let's talk about calculator. So calculator, so the first line of a screenshot is for hypothesis test, so two proportion Z test. So the correct place that you have to go is you hit the stat key. So the stat key is on the left hand side of the left arrow. Hit the stat key and then you go to test and then you select, in my calculator, it's line number 6, two prop Z test, two proportion Z test. Once you select that, there is no data or stats menu. All you have to do is you need two numbers, one for each sample. So in my example, in the first sample, I have the sample size 40, and then the number of success is 23. In my second sample, the sample size is 70, the number of success is 65. So for this example, I put a not equal. So what is the not equal for? What is the whole entire line for? The entire line is for the alternative hypothesis, either a not equal, a less than, or a greater than. That is for the alternative hypothesis. They don't need to know the null hypothesis because the alternative hypothesis affects the p-value. Not equal is two-sided. Less than is left side, greater than is right side. And then the color is for the graph. And then once you hit calculate, you will get a result. So they give you the test statistic, the Z equals to, and the p-value, they give you P1 hat and P2 hat, and the pool proportion, the sample size. So this p-value, let's take a look. Do you see that the p-value is 8.21 blah blah blah, and then E minus 6? So this is a scientific notation. Every time you see this, that means the p-value is very close to 0. So this is 8.22. I use two decimal places times 10 to the negative 6 power, which means you have 8.22. You move the decimal point 6 steps to the right. So this is the exact p-value. So that is very small, so close to 0. So that's why you can reject the null hypothesis. And then if you hit a draw, they will give you the graph, and then they will below the graph, they will tell you what the test statistic is, negative 4.4596, and then the p-value is equals to 0 because you have such a small p-value, and then you divide it by half. So in the graph menu, they will just say, all right, the p-value is equals to 0. And then you cannot see any region below the bell curve. This is because the p-value is so small, you can't even see it. It is there, but it is very small, so you cannot see it. And then the cutoff is negative 4.45 and past the 4.45, one on each side. And then when you do your works online, like WebAssign, they will ask you to calculate this. The sampling distribution follows normal distribution. So P1 hat minus P2 hat follows normal. So all you have to do is you have to type the capital N, and then P1 minus P2, that is just equals to 0. Always equals to 0 because the H0 assumes they are the same. And then the square root part, all you have to do is you do the plugin. So where do you obtain this number? The P hat and the 1 over N1 and then the 1 over N2. Take a look at this menu. Do you see that the P hat, the N1 and the N2 is there? So all you have to do is plug in, you take the square root, and then you do the approximation. All right. So when you do homework online, most likely they will ask you to calculate this. So the first number is a 0. The second number is you grab numbers from the calculator, plug in and then just do that manually. The calculator won't do it for you. You don't see that in the result. This part you will have to do that manually. So that's why in my class, especially for the quizzes and the in-class handwritten exam, I just don't ask students to do this. Okay, because I want them to do all the works in a calculator and then report the numbers straight from a calculator and then give me the conclusion, reject or fail to reject. Okay, so one more line. This is for the confidence interval. So the confidence interval is you still go to stat test. So let me just write down for you. So you still hit the stat key and then you go to test. And then this time you are selecting the 2 proportion z interval, 2 prop z in. And then once you click in, you already carry out the test, right? So the numbers will roll over to this menu. And then for the C level, so if your alpha is 5%, then the C level is 95%. If your alpha is 10%, then the C level is 90%. If the alpha is 1%, then the confidence level, C stands for confidence. The confidence level is 99%. Just be very careful. Where do you get the alpha? The problem will tell you what alpha to use. Okay, the problem will tell you. And then you click calculate, then you will get a confidence interval. All right, so that is the end of this video. If you think this is helpful, give me a like, share, and subscribe, and I will catch you all in the next lesson for more real examples. Signing out.